Hey guys, today we're going to take a look at 1.3, and today we're going to focus on solving equations, so solving linear and also some quadratic equations. Now, solving linear equations, that should be something you're pretty comfortable with. I mean, literally you probably started solving equations in 7th grade, basic equations, and then they got a little harder from there. So we're going to start off, we're just going to kind of get your feet wet. Get a little warm-up problem. I am going to focus on some problems that I see common issues with students having. So let's just jump into this. The first example, we're trying to solve this equation for z. Obviously, there's a couple z's in the problem. But the first thing you're going to want to do is use the distributive property. We want to kind of open up these parentheses. So 9z minus 27 equals 12z. Then we want to get the z's on the same side, get our variables together. Doesn't matter if you move your variables to the left or to the right, you still get the same answer. I usually like to, if I have two variables, I always get rid of the smaller one. If I subtract the 12z to this side, I'm going to end up with a negative with my variable, and if I can avoid that, I'm going to avoid that. Okay, so I'm going to move the 9z to the other side. Negative 27 equals 3z. And then I'm going to divide both sides by 3. And then I'm all done. Okay, I've solved that equation. And I could check that solution. I could plug the negative 9 in for both of those z's, make sure my left and right side equal each other. On the next example, the next example involves some fractions, and that's fine. You can deal with the fractions. Again, if I wanted to get my x's together, I could subtract 1/2 x from 3/4 x, but a lot of you probably are not big fans of fractions, and you avoid them when you can. So what I would do in this case is I would clear my fractions. I would notice this has a denominator of 2, this has the denominator of 1, this has the denominator of 4. If you multiply everything by 4, which is the greatest or the least common multiple is what it's called, but the bigger of the denominators in this case, if you multiply everything, and I mean everything, by 4, okay, so 4 times 1/2, that's going to be 2. So this is now 2x. 4 times 4, even though there's no fraction here, there's no denominator, you still have to multiply the 4 times the 4. You got to be fair. You got to keep everything equal. And then 4 times 3/4, the 4s are just going to cancel. You have yourself a much, much, much easier problem to do. So clearing fractions is important. Fractions, solving equations with fractions is something we're going to talk about a little bit in more depth in Chapter 4. But this example, which is now negative 16 equals x, is all done. But this example also involves fractions. Now this one's a little different. This is, I've got a fraction equal to a fraction that has a special name. It's called a proportion. So in this case, when you solve proportions, you can do what is called cross multiplying. If you have a proportion, their cross products are always equal to each other. So again, if I multiply this way, so 2 times this whole expression, so 4x minus 6. And you multiply this way, so 3 times this whole expression. Again, you've cleared your fractions. You now have just a linear equation where everything's on the same level. You don't have numerators and denominators. Everything's just on the same level. Again, I would subtract my 3x to the other side. Then I'm going to add my 6 to the other side. A lot of you probably would have gone ahead and just done that in one step. You would have moved your x's to the left, you would have moved your numbers to the right, and you would have got that same answer in one less step than I did. Okay? So those are some linear equations. The next example has some equations where there's multiple variables, and we're just trying to solve for like one specific variable. So in all of these cases, we're trying to solve for y. So we're just trying to get the y by itself. So our final answer is going to be y equals, and then everything else is going to be on the other side. So first example, first thing I'm probably going to want to do is I'm going to leave the y where it is. Some people may want to move it to the other side because that'll turn the minus 5y into a plus 5y. Then you don't have a negative to deal with. Nothing wrong with that. Okay, but I'm just going to move the 3x to the other side. All right, so negative 5y equals, and then when you move the 3x to the other side, you're subtracting it. So on this other side, I'm going to have 9, and now I'm going to have minus 3x. Okay, so after you solve a lot of these, you kind of realize that as you move terms from the left to the right or the right to the left, it just changes the sign of those terms. Okay, so this is what I've got now. The y is almost by itself. It's got this negative 5 multiplying it. So we're just going to divide everything by negative 5, and that's good. We're just going to stop right there. There's different ways to write that answer. You can bring the negative out front, but there's nothing wrong with that answer right there. Okay? Now, the next one. This one is an issue because there's multiple y's. We're trying to solve for y, but there's two y's. There's a y here and a y here. And we can't simplify because these aren't like terms. I have an my and an ny. If those were numbers, we'd be good. But for this one, we're going to have to do a different little trick. And it involves factoring. I have two terms that both have a y. That means that that y is a common factor, and I can factor it out. If you take these two y's and factor it out, so you're factoring a y away from the my, so you just have an m, and you're factoring it away from the ny, so you just have an n. Now notice I just have one y. That one y is being multiplied by something, so I can divide by that something. I'm going to divide both sides by m plus n. That'll cancel the m plus n on this side, and it'll move it over to here, where I get my final answer. That's it. Okay? Last one I wanted you to see because we're trying to solve for a variable, and that variable is in the denominator, and you can't do it. You can't solve for a variable when it's in the denominator. So whenever I have a situation like this, the absolute first thing I do is I clear that variable. I'm going to multiply both sides by y. If I multiply this side by y, like that, these two y's are going to cancel, and it's not going to be there anymore. But where it is going to be is over here, because I'm multiplying this side by y. Okay, so I'm going to write this as 3xy equals k minus p. And now I have my y where I can solve for it. That y is being multiplied by a 3x. So I'm going to divide everything by a 3x. Y equals k minus p over 3x. And I'm all done. Okay, that kind of, I was afraid I was going to start, I started to get into that problem right there. So k minus p over 3x. All right, last thing we're going to do is we're going to solve quadratics, and each of these we're going to solve by factoring. Okay, so last class we did some factoring of trinomials, and this was the whole reason that we were doing that, because one of the main methods of solving quadratics is by factoring. So first one, pretty easy. You've got a leading coefficient of 1, so I can just kind of go ahead and factor this. X squared, this has to be an x, and this has to be an x. Now again, notice, well, I'll talk about it in a second. And then factors of 12 that add up to negative 8. So two numbers that multiply together to give you 12 and add up to give you negative 8. That should be minus 6 and minus 2. Okay, again, you can check that. Negative 2 times negative 6 is 12. 6 and 2 are going to give you the minus 8 right there. Now, here's what I have. The reason I factor is because when you factor, you rewrite into a multiplication problem. So what I have are two things that are multiplying together to equal 0. The only way that can be true is if this parenthesis equals 0 or this parenthesis equals 0. The x that would make this parenthesis 0 would be a 6. The x that would make this parenthesis a 0 would be a 2. And those are your two solutions to that quadratic. That's it. plug them in. If you plug in a 6 right there, you're going to get 36 minus 48 plus 12, and that's going to be 0. Same with the 2. Now, for this trick to work, you have to have a quadratic that is set equal to 0. So the first thing I'm going to do on this one, 3x squared minus 13x, I'm going to bring the minus 4 to the other side and make it a plus 4. Now I can factor. So again, I like to use the guess and check method. The only way to factor 3x squared is 3x and x. 4 can be factored into 4 and 1. It could also be factored into 2 and 2. So I'm going to think about, I'm trying to get a negative 13 right here. So I know that 3 times 4 would give me 12. That's getting close to that. So here's what I'm going to do. I'm going to factor 4 into 4 and 1. I'm going to put the 4 over here because I want it to multiply the 3x when I FOIL. I'm going to put a 1 right here. I'm going to notice that I want my OI to add up to be negative 13. So I need this to be negative, and I need this to be negative. And sure enough, if you were to FOIL that, you'd get negative 12x and negative 1x, which would give you your negative 13x. So that is correctly factored. Now, I just need to figure out what x values would make both of these parentheses equal 0. This one's easy. This one's a little trickier. You can either set this equal, most people just set this equal to 0. Take that whole expression, set it equal to 0, and then solve. Move the 1 over, divide by 3, and there's one of your answers. X could equal 1/3, or in this case, x could equal 4. Okay? All right, last one. First off, see if you can factor that one. Try to factor that out. This is what you should have ended up with. Okay? Again, check your OI. That's 2x, that's 5x, that's 7x. Done. I'm right. Okay? Now, I would take both of these parentheses, set them equal to 0, and solve for x. This one, here's what always happens. X equals, if I set this equal to 0, the first thing I'm going to do is I'm going to move the 5 to the other side, so that's going to be a negative 5, and then I'm going to divide by 2. So it's always the opposite of this number divided by that number. So negative 5/2. Over here, it's going to be the opposite of this number, so negative 1, and there isn't anything to divide with, so that's our final answer. Okay? Now, do not get tricked by the next one. The next one is easy. All you have to do on this is just factor out a greatest common factor. Okay? You've got your quadratic term. This is called the quadratic term. It's got the x. This is your linear term. And there's no constant. So just factor out the greatest common factor, which is a 2x. That's going to leave me with x minus 2. And the only way for, so again, I have two things multiplying together to equal 0. For this to equal 0, x would equal 0. For this to equal 0, x would equal 2. And those are the two solutions to that equation. Okay? Next one. That is a difference of squares. There's actually two ways to solve this. One is just to move the 9 over and take the square root of both sides. That'll work. But this is the difference of squares. So I'm going to factor this into x plus 3, x minus 3. So x is equal to negative 3 and positive 3, and I am done. That's all you had to do. Those are the same solutions you would get if you had moved the 9 to the other side and taken the square root. All right, last example. See what you can do. Do me a favor, pause this video, okay, and then try to solve this, and then when you're all done, replay, and you'll see the answer, okay? Pause the video. All right, hopefully you paused the video. You didn't cheat. Okay, I moved everything to one side. I then took this quadratic, and I factored it, okay? I needed factors of 2x squared, which is 2x and x. I needed factors of 1, which is 1 and 1. But I needed both of those ones to be negative because I'm going to end up with a negative 3x right here. So that is the correct factored form. And then the two x's, this one is easy, that's 1. But remember, it's the opposite of this, so positive 1 divided by that. So there's my answer. Okay? Take a look at the rest of the problems, try them on your own, and we will look at them next class. Thanks.